All right, in this video, we're going to look at some examples on how to use the impulse momentum theorem, this equation right here, to solve problems using impulse. All right, so example number one, a 5 kilogram mass has its velocity changed from 2 meters per second east to 8 meters per second east. What is the impulse applied to the object? All right, so here we have mass and velocity. So we're going to use this part of the equation. So we have impulse is equal to mass times delta V. So delta V, remember, is equal to velocity final minus velocity initial. And here we have the velocity is changed from 2 meters per second to 8 meters per second east. So our final velocity is equal to 8 meters per second east. And our initial velocity is 2 meters per second east. So then our delta V is equal to 8 meters per second minus 2 meters per second. So our delta V is 6 meters per second east. So our impulse then is going to be 5 kilograms times 6 meters per second. So our impulse then is 30 kilogram meters per second east. And note also that we can use impulse is equal to the change in momentum. These two things are identical to each other. All right, example number two. So we have Floyd's 3,550 kilogram pickup truck has an initial momentum of 54,000 kilogram meters per second in the positive direction. It experiences a negative impulse of 12,300 Newton seconds. We want to A, determine the change of momentum of the truck. B, the final momentum of the truck. And then C, the final velocity of the truck. Okay, so let's write down what we have. So we have mass is equal to 3,550 kilograms. We have the initial momentum. So P initial is equal to 54,000 kilogram meters per second. Okay. We have the impulse, J, is equal to minus 12,300 Newton seconds. All right. So for A, we want to know the change of momentum. So change of momentum, delta P, is equal to J, which is equal to minus 12,300 Newton seconds. So change of momentum is equal to impulse. So that's equal to the information that we were given in the problem statement. B, the final momentum of the truck. So remember that the initial momentum, so initial momentum plus impulse is going to be equal to the final momentum. So our initial momentum is 54,000 kilogram meters per second plus the impulse, which is a negative 12,300 Newton seconds, which is the same thing as kilogram meters per second. So that's equal to 41,700 kilogram meters per second. Okay, now for C. For C, we want to know the final velocity of the truck. Okay, so our equation for velocity is V is momentum over mass. So we want the final velocity is equal to the final momentum over the mass. So our final momentum is 41,700 kilogram meters per second. And that's divided by our mass of 3,550 kilograms. So our final velocity then is equal to 11.7 meters per second. All right, example number 3. So Johnny is throwing different types of balls against the side of the school. He throws a 0.26 kilogram volleyball with almost no air in it at the wall with a velocity of 3.5 meters per second. The ball hits the wall and falls flat to the ground, so no bouncing back. He then throws a 0.26 kilogram fully inflated volleyball against the wall with a velocity of 3.5 meters per second, which bounces back off the wall with a velocity of 1.6 meters per second. So we want to know which ball has the greater momentum change. Okay, so remember that momentum change is equal to impulse. So impulse is equal to the change in momentum. So let's look at these each. Okay, so for the first instance, when Johnny throws the ball against the wall, the initial velocity is equal to 3.5 meters per second. The final velocity is equal to 0 meters per second. So our delta V then is going to be 0 minus 3.5 meters per second, which is equal to minus 3.5 meters per second. So our impulse, or delta P, is equal to 0.26 kilograms times negative 3.5 meters per second, which gives us a delta P of negative 0.91 Newton seconds, or kilogram meters per second. Okay, for number 2, we have an initial velocity of the same 3.5 meters per second. We have a final velocity now, instead of 0 meters per second, now we have a final velocity of negative 1.6. It's a negative because it goes in the opposite direction. So here we have a delta V of negative 1.6 minus 3.5. So our delta V here is minus 5.1 meters per second. So when we figure out our impulse, or change of momentum, we have 0.26 kilograms times negative 5.1 meters per second, which gives us a delta P of negative 1.33 Newton seconds, or kilogram meters per second. So when the question asks which ball has a greater momentum change, the inflated ball that bounces off the wall has the greater change than the flat ball that just hits the wall and falls to the ground.